Some machines are just different. They aren't the fastest, they're definitely not the prettiest, but they are built for one single, brutal job. And they do that job so well, they become absolute legends. Today, we're talking about one of the all-time greats, the A-10 Thunderbolt II. So this is its official name, the A-10 Thunderbolt II. It's actually a nod to the legendary P-47 Thunderbolt from World War II, a name that's all about power and history. But yeah, let's be real, almost nobody calls it the Thunderbolt. It earned its famous nickname, the Warthog, not because it's sleek or elegant, but because of its rugged, kind of ugly looks and its brutally effective approach to getting the job done. To really, truly understand the Warthog, you can't even start with the plane itself. Nope. You have to start with its entire reason for being, the massive weapon that's at its heart. I mean, this quote right here, it says everything. For most planes, the gun is just one of the weapons it carries. But for the A-10, the Air Force picked the gun first and then told the engineers, okay, now build a plane around this. That's why people say it's not a plane with a gun. It's a gun that happens to have wings.
And why on earth would you build a plane around a gun? Well, it's for one reason: close air support, or CAS. The A-10's whole job is to get down in the dirt, flying low and slow to protect the folks on the ground by absolutely shredding enemy tanks, armored vehicles, and anything else that poses a threat.
So why do they need such a specialized, single-purpose beast in the first place? For that, we've got to go back in time, to the Vietnam War, where the U.S. Air Force realized it had a massive and very deadly problem on its hands. See, after World War II, the Air Force was all in on the Cold War. They were building these incredibly fast, high-altitude jets like the F-4 Phantom and the F-111, jets designed to drop nuclear bombs from way up high. But the reality on the ground in Vietnam was totally different. They needed planes to support troops, and these supersonic jets were just the wrong tool for the job. In fact, get this, the main plane they were using for close air support was this thing, the A-1 Skyraider. It's a propeller plane designed back in the 1940s. And while it was tough, it was just too slow and way too vulnerable to modern anti-aircraft fire. The Air Force lost hundreds of them. They needed something new, and they needed it fast. This huge problem led directly to something called the AX program. That's A for attack, X for experimental. And look at the timeline here. By 1970, the official request went out, and it specifically said the new plane had to be built around a 30mm cannon. Just a few years later, the YA-10 prototype was picked as the winner. Okay, and this is where the genius of the A-10's design really comes into play. Every single piece of this aircraft is a direct solution to the brutal problems of close air support. It was, from the ground up, purpose-built to survive. Let's start with that weapon we keep talking about, the GAU-8 Avenger cannon. It spits out these huge 30mm shells at a fixed rate of 3,900 rounds per minute. The sound it makes is so famous, it has its own name, that absolutely terrifying brute. And the gun is so enormous, I'm not kidding, it's about the size of a small car, that the whole plane had to be built around it. You can even see here how the front landing gear is pushed off to the right side. Why? Because the gun and its massive drum of ammunition sit right on the plane's center line. So what about protecting the pilot? I mean, a plane flying low and slow is just a giant target. Well, to solve that, the A-10 was designed with 1,200 pounds of titanium armor. And that armor creates what everyone famously calls the titanium bathtub. It's basically a protective shell that wraps around the pilot and all the important flight controls. You can see how everything prioritizes survival. The engines are mounted high up, shielded by the wings and tail, making them harder to hit. The whole philosophy was simple. Assume the plane is going to get hit. So it has multiple hydraulic systems with a manual cable-based backup just in case. The engines are placed to reduce their heat signature. Even the landing gear is tough enough to land on a dirt road if it has to. It was literally designed to take an incredible amount of damage and still get its pilot home. All right, so that's the theory. But how did this flying tank actually hold up in the chaos of real combat? Well, the A-10 proved its worth right from its very first major fight. During Operation Desert Storm in 1991, the Warthog was an absolute superstar. It was credited with destroying thousands of Iraqi tanks, artillery pieces, and vehicles. It proved without a doubt that this specialized plane was exactly what was needed on the modern battlefield. But if you want the one story that perfectly captures the Warthog's legendary toughness, this is it. This is the A-10 flown by Captain Kim Campbell during the invasion of Iraq back in 2003. So she's on a mission over Baghdad, and her plane gets absolutely shredded by anti-aircraft fire. She lost all of her hydraulics, and one of the engines was badly damaged. But this is exactly the scenario the A-10 was built for. She switched to the manual backup system, flew that crippled jet for an hour using just cables and pulleys, and landed it safely. It's just the ultimate proof of concept. So that begs the question, right? Why is an aircraft that was designed in the 1970s still so critical for the Air Force today? Well, the answer is pretty simple. It has never, ever stopped evolving. And you can see that evolution so clearly right here. On the left, that's the original A-10A cockpit, with all the old-school analog steam gauges. But on the right, you have the modern A-10C. It's a full-on glass cockpit with digital displays, letting pilots use precision-guided weapons and advanced targeting systems. And it's not just the electronics. We're talking about massive structural upgrades. The Air Force has spent billions keeping these planes in the air, including a program that replaced the wings on the entire fleet. All this work means the A-10 is expected to keep flying all the way to 2040. Which really brings us to the big question, doesn't it? In an age of stealth fighters, drones, and high-tech everything, there's still nothing that can really do the A-10's dirty work quite like the A-10. So after 5 decades of service, you have to wonder, can a design this brutally effective, this focused on one single job, ever truly be replaced?